So these are called, actually, when I make a function call here, I define a function called myFun1 with the parameter x. X is an integer value, okay? And then inside the method actual definition, I declare a local variable called y, and y equals 2 times x plus 3, and return y. And then when I actually make a function call, I need to provide a value. myFun1, I need to provide a value. The value here is a. A is assigned 20. So when I actually make a function call, the parameter argument a will be passed to the parameter x. So the x get to 20. Okay. So then I calculate the y. So the local variable y equals 43, and the 43 is returned. So when the return of 43, the return value is going to be assigned to b, and b get 43. That's pretty simple. Okay. Now, what about if I define a method? And I still have a return value, but I call myFun2. Now, in this case, in myFun2, the parameter I define here will be a array. So it's int square bracket x. So x is actually passed as array. So what about this case? Okay. So then in the implementation, I'm going to say, okay, I define a local variable y. Okay, so the local variable y here and here are not the same because they are local. And then I'm going to say y equals, because x is passed as an array, so I'm going to put like something like say x0 plus x2, and I return y. Okay, so x is array. Now here, myFun2 is a method, but it can actually pass the array. Now what happens here? So let's see. In the main method, what I'm going to do here is I'm kind of running out of space, so I have to erase this. Okay. Okay, so I'm also going to erase this. Okay, I think oh, well, that's okay. So now the parameter is an array. So when I actually call the method in the main function, I should actually provide the argument, which is array, right? Because here's array. So then I'm going to say, I'm going to declare an integer, let's say array, okay? I'm going to say A. A is declared as an array. And then I can, to make it simple, I just initialize the value of A during the declaration. So I'm going to put the 1, 2, 7, 4. So that means A is declared as an array of integer with 4 elements. The first element A0 equals 1, A1 equals 2, A2 equals 7, A3 equals 4. So the last index is A3 because there are only total of 4 elements. Okay. And then I declare another variable B. It's an integer. And then I'm going to call my fun 2, because I'm going to call this one. And then I provide A. The my fun 2 going to return a value, integer value, and I assign to B. Now, if I actually try to print the return value, what value will be printed out? Take a look at this very carefully. So, oh, I'm sorry. Oh yeah, I think it's correct. So here's the deal. So when I make a function called myFun2 and I provide A, which is array, I have to provide an array as argument, right? Because when I define the function myFun2, the parameter is an array. So in that case, so when I call this method and I pass the array A, which contains 4 elements, to the parameter array parameter X. So A gonna actually pass to X. So what do you think? What's the value of X? X0. What do you think? X0 should be the same as A0. Is this a reasonable assumption? Now, what about A2? X2, I'm sorry. So I assume that the A is passed to X. So each individual value of A will be passed to the array, each individual element of array X. So X0 going to be 1. X2 will be, what is the value of X2? Let me check. Does everyone type anything here? No. I don't get any answer for this. What do you think? What's X2? So X0 is 1. X2 is 7, right? Is everyone against me? So then 1 plus 7 equals 8 assigned to Y, and then I return Y. So the returned value is 8. So 8 will be assigned to B, right? So when I print B, which value will be printed out? 8, right? Now, how this Java actually deal with that kind of scenario? Does the Java actually do the same thing as when a Java passed array? Does the Java actually do the same thing as it does to the primitive data type integer? Now let's take a look at this. So when I actually declare A as an array and assign a value 1, 2, 7, 4. So I declare A as an array. So A is declared as an array. Okay. Now, how this array thing gonna work in Java? Here's what it is. When I declare A as array, so A is Java reserve a space for A. Okay, typically the space is going to be like a 32 bits. So, and then once the A assigned a value, so that means each of the element of A has been, initialized. Then Java going to reserve a space in the memory, which the space contains an object. The object actually contains 4 elements. Each element is an integer type. Now it's initialized as 1274. So the first, I don't know why this. That sucks because actually everything's disappeared. I don't like this. Anyway, let me actually reproduce that. Um, so man, that's not good. So that's the class. So I def public static int my fun 2. So int x. So then I declare the int y equals, actually not equals, y equals 2 times x plus, I'm sorry, that's not the one I'm talking about. It's actually, so it is actually x0 plus x2 and return y. Okay, I quickly reproduce that one. And then the public static void main method. Okay, whatever it's inside the parameter. And then I declare an int a. Oh, I'm sorry, that's not. No, that's not the one. Okay. A 1274 and the int b. So then I assign b to my fun 2a, right? So then I print dot print lnb. Okay, I quickly reproduce that one. So when I actually Java declare a as an array, so a going to be allocated space. Okay, and then when I initialize the value for a, so Java going to actually create an object which contains each of the value for the element. So 1, 2, 7, 4. Each one is an integer. Okay. Now a is array variable. Now once the Java create an object, Java gonna remember what is the memory address. Okay, the memory address of this object. So Java gonna actually record the memory address and put the memory address of this object into the area here called a reference. So A gonna store a reference, which is the memory address of the object, which stores the array variable, array data. So for example, if the memory address for this object is 100, okay, and then Java gonna put the 100 in this array element. So this basically it's almost like you actually point A to this object through the memory address, and we call it reference. Now, when Java actually define a method which actually use the array as a parameter, so then the Java can also create an array variable. Array variable contains the reference area. Now, so far, x has not been initialized. So if x does not have any value, so there's no actually object x can point to. Okay. Now, what happens is that when actually I make a function called myFun2, and I pass the array a to this array variable x. Okay. Now, which value Java gonna pass? Where Java actually, when actually assign a passed array a to array x, array variable x, does the Java gonna create another object and then completely copy this object 1274 to this this local area and point x to that object? When I make a copy, I cannot use the same memory address. This memory address could be 900, right? So then I put the 900. So x point to the memory address 900, which contains the object. That object contains the value of the array element 1274. Okay. Now, when Java passed array variable a to array variable x, does the Java do this? That's one. That could be the option, right? And the reality is Java does not do this. Okay. Java does not do this. What actually Java does is, okay, Java actually does not create a separate object and copy this object value to that separate object. No, Java does not do this. Now, what does Java do? What does Java do? What the Java does is when you pass the array variable a to array variable x, Java actually copy the reference of a, which is 100, to the reference of x. So the value 100, which is memory address of the object, 100 is copied to x. And Java does not create another object which contains the whole value of array elements. So Java just basically, when you pass the array, when Java passed the array variable to another array parameter, Java just basically copy the reference value, which is the memory address of the object, to the array variable x. Now, what does that mean? So that means x actually also points to the memory address 100. Okay. So x and a basically has the same memory address, has the same reference values. And x points to the same object that a points to. Okay. That's basically the meaning of the, when pass the array variable a to x. That's called the reference passing. Okay, that's called the reference passing. Now, what's good about the reference passing? Now, when I use it, when I call this array, and then I'm gonna find out a gonna pass to x, so so it just forced the x the array actually variable x points to the same object that A points to. So that means when I actually refer to x0, I'm actually refer to 1. x1 refers to, x2 refers to 7, x3 refers to 4. So it's the same, x0 is the same as a0, x1 is the same as a1 because x and a points to the same object. Okay, so that actually works. So x0 is 1 because a0 is 1. x2 is 7 because a2 is 7. And then a return value. And also, the good thing about this, what's the other advantage about the reference passing? What's the other advantage of reference passing? For the reference passing, you actually you don't create additional object. So what about if the array A is a very huge array? Okay, if array A is huge, if array A contains 1 million elements, array A contains 1 million elements, A0, A1, A2, A3, all the way to A, not 1 million, just A 1 million minus 1, right? um, and then when I pass this 1 million elements to a method, I'm not going to create an object which contains 1 million elements. I basically simply create another array elements that the point its reference to the same object. So both A and X point to the same object. So this is going to save a lot of memory space. Okay, that's a good part. But there's certainly some kind of a drawback when you copy, you passing when you're passing a reference. Okay, passing the reference is basically just to do the copy for the reference value, not the actual object. Okay, now this copy, sometimes we call the shallow copy. When you copy a array to another array, and then you actually create another object and copy each value, each element in the object to another one, and point that actually array variable to that one. And that kind of copy is called deep copy. Okay, that's a difference. And we're going to discuss more about reference passing, okay? Because reference passing is very interesting because when you pass the, when you call the method and pass the array, you pass the reference. And there's a side effect for this. There's certainly some kind of advantage for reference passing, but there are some, I'm not going to call it disadvantage, but it's kind of side effect. You have to realize this, but otherwise you're going to make a mistake. Okay. Now we're going to stop this for now, but we will be back and talk about array parameters again when we talk about method. Okay. So the next topic we can talk about is a scope. Okay. Scope of a variable.
Professor, I have a quick question before we move on too far.
Yeah.
So I've done some C++ work where you have pointers that act as references to other objects. Yeah. Is this just another way of doing the same thing, or is it completely separate?
It's the same thing. When you actually work on a C++, if you copy any array as a reference copy, then that's the same as this. When you talk about reference copy, you basically only copy the address. You don't actually create another object. Okay, you just copy the reference and so for example, let me actually give you another example. Say I have array, say integer, array x, 1, 2, 3, 4, 10. Okay, and then I declare another array in array variable y. Okay, so when I make a copy like this, so I'm gonna say y equals x. What does that mean? That's called a reference copy. So when I actually declare x, so x, okay, so then when I initialize the value of x, so x is actually defined as an array of 5 elements. So I'm going to create a object which contains 5 integer elements, and I assign a value 1, 2, 3, 4, 10. And then once I actually put this element in the memory, I'm going to remember the address, and I put the memory address as a reference here. Okay, so x actually points to that reference. Okay, when I declare an element of y and I create array element of y and with a reference area. Now y hasn't assigned a value yet, right? Now when I actually say y equals x, so basically I can assign the value of x to y. Now the question is, do I actually copy a complete object to y? So 1, 2, 3, 4, 10. So then I just copy each individual value to y, and I create another y. Actually, whether it's a C++ or Java, they actually don't do that. Basically, what when they copy x to y, they actually mean I copy the reference of x to y. So if the reference is 100, 1000, I actually copy this reference value 1000 to y. So y got the same reference value, which actually points to the same memory address. Okay.
So then if I change x, y also is changed the same way.
If you change x, y, the value of y is going to change too. And if you change y, the x value is going to change too. So x, y are basically they are just a different array variable name, but they both point to the same object. So if the actual object value change, they're going to change. If I change one, the other one going to change too.
Right. Thank you.
Yeah, that's called a reference copy. Now, some people say, well, that's one way, but what about if I really want to make another copy of the object? So I want to make another copy of the object and point y to the other one. And that's called a deep copy. When I make a deep copy, then you have to copy each individual element. Okay. You have to create so that's a different approach. So, but the reason for this, I can explain this because in most case, when you deal with a big array elements, both Java or C language or C++, they don't want to actually increase the memory usage, so they use the reference for the array. But there's definitely some kind of side effect. Now, like you say, if I actually copy x to y, and then I change y, I also change x, right? That also happens with the memory passing. If the memory pass the reference, okay, if I change anything inside the memory, inside the method, for example, here, that's a good question. Let me say, what about if I say I add another actually statement here? So if I say, okay, x3 equals 20, x3 equals 20 inside this method. And then when I come back, Okay, if I want to print a system out dot print ln dot a3, what do you think? Which value going to be printed out? If I change x3, a3 going to be changed too. Do you get the point here? Because x and a points to the same object. If I change x of 3 from 4 to 20, I also changed a3, right? So when I print this out, a3 should be printed as 20 as well. That's the side effect. Yeah, thank you. Good, good point. So now for the scope of variable, I'm not going to talk much about this. So every time when I declare something in a method, declare a variable like an integer x as an integer in a method. That's the scope of this variable is inside this method. So if I declare x as a method inside a method, declare this variable inside a method, then when the method is actually completely finished, then this variable going to be gone. No one actually outside is going to actually know what happened. Okay, so that's basically the scope of a variable. Now, there's one issue we need to we need to actually you must be careful about is, what about if someone let's say next one. Okay, what about if someone wants to declare variable in different scope, and they declared the same variable? For example, let's say public class. So my class. Okay. Now I declare a variable inside the class. But outside any method. Okay, then I define a method. I call the fun. Okay, so let's say int a, whatever. Okay. So then I can actually use this variable inside the method. So if I say int y equals int y, so y is a variable defined inside the function. So y is not known outside this function. But I can still use the x inside this, right? Because x is declared in the class, and I can use the inside. And x is called a field variable. Now, actually, when I declare x, I should actually say declare x as a class method. Normally, I'm gonna actually use declare. I have to declare an instance of class, and I use the instance of a class name dot x to refer to the x. But I just assume this. So x should be, if initial value of x is 10, so when y equals x, the value of x is 10. 10 assigned to y, so y is 10. Okay, so this is okay. So x, if I declare it here as a field variable, it's recognizable, accessible inside the method. Okay. Now, one thing you must be careful about is this. I declare a variable y, which is 20, as a field It's called a field variable, which is actually inside the class, but outside the function. And then y is also declared inside the method. So y is declared here and declared here. Now, what's the problem? In this case, so you probably will be confused. What is this y? Is this y a local variable, which is defined in the fun, or the field variable, which is defined outside this method? Now, in Java, if this thing happens, if the same actual variable, if the field variable and the local variable use the same name, then in the method, this y going to refer to the local variable. So this field variable is not accessible. Okay, so this is what's the rule over here. If a method is a local variable, okay, if a method's local variable has the same name as the field, then in that method, the name refers to a local item, and the field is inaccessible. So if I put the int x equals 10 or y equals 10, then y equals 10 inside this. But outside this method range, y is 20. But inside this, y is 10. Okay. Now, for good practice, try everything you can to avoid this kind of scenario. Okay. You are not going to run out of variable name, right? So you have enough variable names. Why you want to use the same name for the field and for the local? You are looking for trouble, because in this case, you actually cause the confusion. So try as much as you can to avoid that kind of scenario. Don't use the same name for, for the variables in the different scope. Okay, that's basically the idea. Okay, now because if you use the same name, it will cause some kind of confusion, and sometimes this is called side effects. Okay, let me actually give you example, and you can understand what do I mean for the side effect. Okay, so let's say, okay, let me actually show you this example. Let's see what it is. Okay, I'm actually show you the Java code here using the rep.it is my repo, and the M2B. Okay, now here is a Java code. Can you see this? I define a class called a side effect class, and I define two variable. These two are field variable, which is defined in the class, but outside the two methods. The do something, that's one method, and the main, that's the other method. Just remember, for every program you write, you always should actually contain the method called name main. That's the entry level. Okay. Now, so I declared field. One is called a field var1, field var2. Okay. Both are initialized to 0. Now, inside the method do something, I declared in field a field var2 also as a local variable. So a field var2 is declared as both the field variable and a local variable. And remember, based on the rule, based on the Java, actually, the rule of the Java. So if I declare as a local variable, and then inside this do something, a field var2 is interpreted as a local variable. And the field variable field var2 is not accessible. So in that case, a field var2 is actually 1, right? Not 0. Remember that one. So then I'm going to do a little math. A field var1 equals a field var1 plus arg1 arg0, and a field var2 equals a field var2 plus arg1 0. And I print out the two values. Okay. And then I have a main method. In the main method, I declare an instance variable, a class instance called my class, which is actually an instance of side effect class. Okay. So then I'm going to do something using the instance object for the class. Don't ask me how you're going to do this, but basically, when you actually define a class, you can also define the instance of class, and I call this method. And do something, I pass the values 1 to the argument 0, right? 1 going to be passed to the argument 0. So the argument 0 is 1 in this case. Okay, so now when I do this, a field var1 equals field var1 plus arg1, arg0. So field var1 is a field variable, which is initialized as 0. So this is 0 plus arg0, which is passed as a 1. So the field var1 becomes 1 after the assignment, after this operation, right? A field var1 is 1. Just keep that in mind. A field var2 is equals field var2, which is 1, because this is interpreted as a local variable, plus 1. So this is 1 plus 1, and the field var2 is 2, right? So this is a 1, this is a 2. So if I print out inside do something method, this is actually the output going to be. So let me actually compile this. Java C and the side effect side effect class Java. What's the name? Okay, so then I run this method Java space side effect class. Okay, so I print this statement, and this is in class. So that's this. So in the in class, the field var1 is 1, which is expected, right? Because the field var1 is a field var1 plus arg1, and field var1 is initialized to 0 because it's a field method. Okay, arg1 is 1, so 0 plus 1, and this is 1. And the field var2 is 2. That's also expected because field var2 is a local variable. Forget about this one here. Forget about this. It's now a local variable. A local variable assigned to it, and then plus 1, which is arg0, which is 1, and a 1 plus 1, and this is 2. Any questions? Any problem with this? If I move forward. And then when I finish the function call, do something, and I try to actually print out in the main method. So in this case, a field var1 is the field actual variable, right? But this field variable is changed inside the do something. Inside the do something method. So the field variable field var1 is changed inside do something. So that's why it's 1. Okay. However, the field var2 is still 1. Why? Because field var2 is initialized to 0. It's still so when I print field var2, it's still 0. Why? Because everything changed inside this do something. That field var2 is local variable. So you actually in the do something you change the local variable, but you never changed the field variable. So it's still printed out as 0. little confused, right? But that's how Java going to deal with that kind of situation. That's the reason why I strongly recommend that you don't use the same name for 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 different variables in different scope. Okay, this is going to cause confusion. That's the confusion. Okay, because everything changed in the do something method. Everything changed in the do something method for a field var2 is a local change. Okay, because in do something method, this field var2, a field variable is not accessible. Everything inside represent a local variable. So once actually you finish the do something method, the local variable going to disappear. It will be wiped out. Now this field var2 is actually represent a field variable. But field var1 is different because it's not declared in do something. So the field var1, even in the do something method, it still represents a field variable. It still represents that variable. So it's changed. Okay. So that's the side effect, which is not good. That's the reason why you should avoid this. Okay. So once you declare a variable in a different scope, use a different variable name. Okay, not the same one. And also a method has a scope. Okay, if the method is declared in a class, then every actual method in a class can call this method. Okay, that's the method scope. Now the next topic I want to talk about is called method name overloading. Now this is actually a good feature of Java, and also a good feature for C++. If you now C++ and Java are basically similar, in terms of the syntax, which is kind of good. Once you know how to use the C++, it's very easy for you to learn Java. There's a slight difference in terms of some of the command, but in general, the syntax are very similar. So now the program actually, Java program allows something called method overloading. Okay, so which basically means that Java allows you to define different methods with the same name. Different method with the same name. Okay, so in the Java class, I can define a method, 3 different methods. Let's say I can define this. Okay, public, static. Okay, I can return an integer value, and I can define a method called sum. So inside I have an int x, int y. Okay, so I can define a local variable x, int z, and z equals x plus y, and I can return z. Okay, so the method is going to return an integer as well, which is the sum of x and y. Also, I can define another method called sum. Okay, I can use double. I call it sum and double. So then I can say double z, or double, I can use a. Okay, so then a equals x plus y, and I return a. Now these two methods also both called sum, but the import parameters, the parameters actually passed. This one is integer, right? This one's double. Okay, so they're not the same. And I can even define another method called public static. I can define as integer sum, and then I have an int x, int y, int z. Okay, so then I can define a p, int p. So p equals x plus y plus z, and I return p. Okay. So I define a three method called sum. One is int and double, and then this one's int. Now you can find out, even though these three methods are basically use the same method name, but their parameters are different. This one has two parameters, both first int, second int. This one has a two parameter, first double, second double, and this one has three parameter, int. And I basically call these signature. Okay, I call this signature. Okay, now these three methods have different signatures. Okay, now this is important because when I make a method call in the main method, let me continue with the previous one. If I'm in the main method, when I make a function call, I can declare, say, x, y, z, and I say x equals 1, y equals 2, z equals 3, and then I declare a double a, b, and I'm going to say a equals 2.3, b equals 1.4, okay? And then when I make a function call, I'm going to say int p equals sum xy. And I can make another function call int q equals sum x, y, z. And the double r equals sum a, b. So I call the function sum, but the first one I call sum a x, y, and the second one I call sum x, y, z, and the third one I call sum a, b. Now, what's the difference among these three different function calls? What's the difference among these function calls? The first one I call the sum, and then I'm gonna figure out which method I actually gonna be called, right? And then what the Java gonna do is Java gonna check the signature. The signature says the first one is x, y, and what's the value of x? X is 1, which is integer. And the second one, y equals 2, which is integer. So I check the signature, which is integer. So now you tell me which function, which method Java gonna call. The first one, right? The Java gonna call the first one. Now, which method does Java gonna call? Is Java gonna call? Which one?
I'm sorry, were you showing the input on the previous slide?
For this second one. Sum x, y, z.
It'll call the method with 3 integers input, so the third one.
The third one. Okay. And the last one is sum A and B, and A is double, B is double. So A is 2.3, B is 1.4. So then you're going to call this one, right? Because it has a signature double, double. Okay. So Java allows you to define many functions with the same name, as far as these functions have different signatures. When you make a function call, you have to make it clear. Okay, what is your signature? If the function actually, if the method defined using the parameter all like an integer, like 2 integer, then the first actual method is going to be called. Okay, that's called a method overloading. Now here's another example. So I have a class called a data printer, and then I define 2 methods. One method is called a data printer, and the second method is also called a data printer. And then the parameter here. The parameter is current day, which is integer, current month, which is also defined as integer, and the current year, which is defined as integer. Now the second method, I have a current day, which is defined as integer, and the current month defined as a string, and the current year defined as integer. Okay, now if I look at the signature, that's int, right? And that's int, string, int. If I look at the signature of these 2 methods. So when I actually, in the main method, when I actually make a function call, when I call data print, if I provide 37,212 or 2012, which method are you going to call? I'm going to call.
We'll call the first one that uses that takes 3 integers as an input.
Call the first one. The second one, look at the signature. It's a int, string, int. So you're going to call the second one, right? And then it will print a different variables. It will print a different actual one. So this one going to print out as the first one. You're going to print out as 7. Current day 30, 2020, 2012. Now this one will print out as month. That's string. Month is a string. So I'm going to print out as July. Concatenate with a space and the current day, which is 30, and then comma and 2012. So if I call this, you're going to print out as July 30th, 2012. And if I call this, you're going to print out as a 7/30/2012. So that's the memory, method overloading. Okay. This is actually very powerful actually feature for the Java. So in most of the library methods, you will find out each method may use the overloading. So you can call the method if you provide different parameters, arguments, then it will perform different operation. Normally, when you use method overloading, you basically try to implement method in a different way, but they should be a similar methods. Like this case, data print. Both cases going to print the data, but in different format. Okay. Now, method loading, we try to avoid the scenario that you use the method loading and define one method as this, and the other method is completely different feature. That's not recommended. So when you use the method loading, it's something like they basically perform the similar activity, but use a slightly different signature. So in that case, you can use the method loading. Okay. Now the other one we're going to talk about is this, use the scanner method in methods. Okay. So that's something we're going to talk about. And if I actually, I can actually post these two methods in there. One is called so I can actually post these two methods on the Blackboard. So I will explain this next time on Monday. So sometimes you can actually, the the idea is that you should actually, if you want to use a scanner, try to define the scanner, try to create a scanner object in the main method. Okay. Once you create a scanner object, you pass the scanner object as argument, okay, to the method. So all the methods are going to use the same scanner object. Instead of actually you create a different scanner object in each of the method. Okay. So why you want to do this? Because when you create a scanner object, it's going to take some time in Java. So if you actually create a scanner object each time when you make a function call, when you call the function 100 times, you're going to actually, each function call, you're going to create a scanner object. That's going to, cause some performance issue. But if when you create a scanner object in the main method and pass as an object in each of the method call, and when you call the method, you just actually import the value. You don't have to create a scanner object because you only use one scanner object, which is created in the main method. Then this is going to save you time. Okay. You're going to increase the performance. So that's probably something we need to be careful. We're going to actually I'm going to post two methods, okay, on the Blackboard. And you tell me what's the difference between these two, because they have the same effect. They're going to create a same import, same output, but the Java going to run, in slightly different way. Okay, one going to create a lot of scanner actual object. The other one only use one scanner object. Okay, I think that's pretty much all for today. So we're running out of time now. So, so do you have any questions?